First, we started in the first lecture. We saw certain concepts related to motion, which were rest. Then we also discussed about the motion, then the different types of motion, which included the rectilinear motion, circular motion, rotational motion, and all that. There were also one-dimensional motion, two-dimensional motion, and three-dimensional motion. We also discussed about the distance and the concept of speed, their SI units, their what type of quantities they are, whether they are scalar or they are vector. We have also discussed the types of speed, that is uniform speed, non-uniform speed, and average speed. Then we also discuss about the displacement and velocity, their SI units, their different quantities, and also about the acceleration. And now we'll be starting with our next topic, that is now uniform and non-uniform motion. Okay, so first we'll see what is uniform motion. So when an object covers equal distances in equal intervals of time, it is said to be in uniform motion. We have also seen this before, right? For the concept of uniform speed, where equal distances were covered in equal intervals of time, right? So we can also say that whenever there is a uniform speed, we will see a uniform motion. Whenever there is uniform speed, we'll always have a uniform motion. We have discussed this before in the concept of the uniform speed. Whenever we'll have uniform speed, we'll always have a uniform motion, as uniform speed also states the same thing, that when an object covers equal distances in equal intervals of time, it is said to be in uniform motion, and it is also same for the uniform speed. So next we have the second type of motion, that is non-uniform motion. It states that when an object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. And this same was there for our non-uniform speed. This we same discuss for our non-uniform speed. So which we can, with this we can say that whenever there is non-uniform speed, we'll get a non-uniform motion. Okay, and non-uniform motion is when unequal distances are covered in equal intervals of time, and it is also same for the non-uniform speed. And non-uniform speed we have discussed already. Now we'll discuss some points related to this uniform and non-uniform motion. See, for an object to be in uniform motion, whenever an object is in uniform motion, no force is required. No force is required for an object to be in uniform motion, which means whenever an object will be in uniform motion, there is no other force acting on it. The next, and it is very important point, please make sure that you write this in your notes. Then the next point is the direction of the object moving with constant speed in circular motion is changing continuously, and it is given by the tangent at that point. What? The direction of the object moving with constant speed in circular motion. Circular motion, we have discussed earlier what is circular motion. Whenever an object moves in this way, in this type of circle, it is called as circular motion, right? With constant speed. Constant speed means we'll see a uniform motion. And whenever an object is performing such type of motion, it is changing its direction continuously, and this direction is given by the tangent at that point. Say if we want to check its direction at this point, so we'll draw one tangent over here, and this tangent will give us the direction of the motion at this point. Say if we want to check our direction of motion at this point, so we'll draw one tangent at this point and we'll get the direction of the motion at this point. So if we want to check our direction at this point, the third remaining arrow, so what we'll do, we'll draw a tangent. We'll draw one tangent at this point like this, and we'll get the direction of the motion. The same you can see over here. Got one diagram for you. This, check this. So if we want to check our motion, direction of motion at this point, so we'll draw one tangent. See, this is our tangent, and this will show the direction of our motion. The same is there for this point. See, there is one diagonal drawn over here, and this tangent drawn over here, and this will show us the direction of the motion at this point. Same for this point, and same will happen for this point. This arrow, which is the tangent to this point, will show us the direction of the motion at that point. So now moving on to our next point. If an object is in circular motion with constant speed, it is in non-uniform motion. We have already discussed that whenever we'll get constant speed, it will always be in uniform motion, but it is saying it is in non-uniform motion. Why? Now we'll check that. As the velocity is changing continuously, here velocity is changing continuously due to change in its direction. We have seen in the concept of displacement and velocity that whenever there is a change in direction, there is the change in its velocity. And as velocity is changing, there is change in the motion. As velocity is changing, will not get a uniform velocity, and as there is no uniform velocity, there will be a non-uniform motion. Okay, so as velocity is changing continuously due to change in the direction, we'll see that we are getting a non-uniform motion. Okay, so we have discussed the uniform and non-uniform motion. Now we'll move on to our next part, that is the graphical representation of motion. We can show a motion of any object using a graph. The first case 1, when the object is at rest. When we say that an object is at rest, when there is no displacement, means the object is at rest. And see, the displacement is constant. This is our displacement time graph. It is also shown over here that we are discussing it on the displacement time graph. So see, if you are observing the furniture in your house, say you are sitting on the chair over at this point A, say this is your room, and some furniture is kept in this corner. Already there is some distance from you to this, so this distance is shown by this gap. Okay, this gap shows the distance between you and the object. And as the time is passing, say for 1 second, 2 second, then we'll have 3 second, 4 second. As the time is passing by, there is no change in its position. It is still at its position there only. So the displacement is constant. The distance between you and the furniture is constant and it is not changing. See, you can also check in this graph that there is no change in the displacement. It is constant throughout the time. Now check here, as there is no displacement, there will be no velocity time graph. And even if there we try to draw a velocity time graph, so it will be like this. See, if this is a velocity time graph, if this is a velocity time graph, as there is no displacement is not happening, so velocity will be zero. So we will get a velocity along our x-axis or the axis of the time. It will be same as that of the our time axis. This will be our velocity. Okay, so velocity here is equals to 0. Now we'll check our case number 2. We'll check our case number 2. When an object is in uniform motion. Our object will be in uniform motion when it covers equal distance in equal intervals of time. In equal intervals of time. Now check. So we can see there is displacement on the y-axis and there is time on the x-axis. So we'll call this graph as the displacement time graph. So as we have said that equal distances in equal intervals of time. Say if an object is covering 1 meter in the first 1 second, and then another 1 meter in the another next second, which will be like 2 meters in 2 seconds. It will be 2 meters in next 2 seconds, and then next again 1 meter in next 1 second. So we can call this as 3 meters in 3 seconds, right? So if we try to plot this situation on this graph, see, we'll take 3 instances, that 1, 2 and 3. This is our time: 1 second, 2 second and 3 second. Now we'll mark the same for the displacement. Say 1, 2, 1, 2 and 3. Okay. So for first, we'll check for this situation. Our first situation, we'll try to plot this on our graph. See, this is our first displacement, 1 meter of displacement taking place in 1 second. Then second instance, that is this 2 meters in next in 2 seconds. See, this is we are covering 2 meters in this 2 second time, and then this 3 meters in 3 meters of time. So whenever we'll get such type of graph, when we are getting a straight line like this we are getting a straight line, we'll always have a uniform motion. We'll always have a uniform motion. So whenever we'll get a straight line, we'll always have a uniform motion. And you can see that for uniform motion, we need to cover equal distances in equal intervals of time. And we have taken 3 instances, that is 1 meter in 1 second, then another 1 meter in 1 second, and another 1 meter in 1 second, right? So for this, we plot this type of graph, and whenever we'll get displacement time graph with a straight line on it, it will always be a uniform motion. Okay, now we'll see our next graph. Okay, so for uniform motion, now we'll discuss about the velocity time graph. what will be the velocity time graph. So as there is equal change in distances in equal intervals of time, equal distances in equal intervals of time, so which is example of non-uniform motion. And we know that the time rate of change of this distance is our velocity. We had checked, or we have discussed this before when we were discussing about our velocity and speed. So our speed was rate of change of distance. And for velocity, we'll just change this distance to displacement, right? So as we are changing equal distances in equal intervals of time, so our velocity will be constant. Velocity is change in displacement, or when we discuss about the speed, it is change in the distance in unit time, and it is same for all intervals of time. Okay, so for that purpose we draw a straight line parallel to the x-axis. When we'll be drawing a velocity time graph for a uniform motion, we'll get a line parallel to the x-axis, or the line parallel to the axis showing the time. Okay, so for a uniform motion, if we are drawing a velocity time graph, the velocity time graph will always be parallel to the time axis or the x-axis. I hope it is clear till now. And here velocity is constant. See, check this point. Here velocity is constant. So there will be no acceleration, and there will be no acceleration time graph. And even if we try to draw the acceleration time graph, it will be, see, like this. If we try to draw a velocity acceleration time graph, so this is time and this is our acceleration. As the acceleration is not there, means acceleration is equals to 0, so it will be equals to this line. Acceleration will be along the our x-axis, or the axis which is for there for the time. It will not come over in this area, will not get any thing in this area in the x, or in the area between the x and y axis. Will get our graph only on this x-axis part, which is on the time, as the value of acceleration is equals to 0. Okay, so now we'll moving on to our next case. So our next case is when an object is in uniformly accelerated motion. Uniformly accelerated motion. Uniformly accelerated means the value of acceleration is constant. Acceleration is and we have seen that the formula for acceleration is final velocity minus initial velocity upon time, or rate of change of velocity is called as the acceleration, and acceleration is given by this formula. And as there is change in velocity, when there is change in velocity, there will be a change in the rate of change of displacement. So for that purpose, our displacement time graph will be like a parabola. See, you can check this. This is in the form of a parabola. It will not be a straight line. This will be a parabola. The displacement time graph for a uniformly accelerated motion will always be a parabola. Okay. So now we'll move on to the next case. That is the velocity time graph for uniformly accelerated motion. Now here we saw that, check this formula for acceleration: A equals to V minus U upon T. Our acceleration is rate of change of velocity upon time, and as the acceleration is constant, means there is constant change in the rate of change of our velocity. So we'll always get a straight line for uniformly accelerated motion. When there is uniform acceleration performed by an object, we'll always get a straight line for its velocity time graph, because there is equal change in velocity, equal change in velocity in equal intervals of time, in equal intervals of time. There is equal change in velocity in equal intervals of time, and because of which we get a straight line for a velocity time graph for a constant acceleration. Okay. So whenever there will be a constant or uniformly accelerated motion, if we plot it in terms of velocity time graph, we'll always get a straight line. This is same for uniform motion when the velocity was constant, and when velocity was constant, our displacement time graph was also same. And when there will be a constant acceleration, we'll get a straight line for velocity time graph. Okay, so now we'll move on to the acceleration time graph. We'll now see how we'll plot the acceleration time graph. See, as it is a constant acceleration, means there is no change in the acceleration if we go with the time. As the time is changing, as the time is increasing, there is no change in the acceleration. So acceleration is constant. See, there is a value of 1.5 over here, and it is going constant with the time. There is no change. It is 1.5 throughout the time. So whenever we will be plotting a acceleration time graph for a constant accelerated motion or uniformly accelerated motion, we'll always get a line which will be parallel to our x-axis, or the axis which will be showing the time. Okay. So now there are some points related to this concept. It says that zero acceleration is not same as that of constant acceleration. Some of you must be thinking that zero acceleration throughout the motion must be also same as that of constant acceleration, right? If there is acceleration of say 1 meters per second square throughout the motion, and there is also an acceleration of 0 meters per second square throughout the motion, and this value of 0 is also not changing, and this value of 1 is also not changing throughout the motion. But then we should also say that this 0 meters per second square and 1 meters per second square both must be showing a constant acceleration, because the value of 0 is also not changing and the value of 1 is also not changing throughout the motion. So can we say that zero acceleration is also same as that of constant acceleration? But it is not going to happen. Zero acceleration will not be a constant acceleration, but we can say that 1 meters per second square of acceleration throughout the motion is a constant acceleration. And why 0 meters per second square or zero acceleration is not same as that of the constant acceleration, we'll check in this statement that zero acceleration is not same as that of constant acceleration, as constant acceleration will have some magnitude, but zero acceleration will have no magnitude. There will be no magnitude when we will be seeing zero acceleration, right? Whenever there is zero acceleration, अगर acceleration zero है तो उसका magnitude भी तो zero है. यहाँ मतलब यहाँ पर कुछ magnitude है ही नहीं. There is no magnitude for this type of acceleration, and whenever there is no magnitude for an acceleration, we'll call it as zero acceleration. And our zero acceleration is not same as that of constant acceleration, because constant acceleration will always have some or the other magnitude. It can be positive or it can be negative, but for an acceleration to be constant, the acceleration must not be equals to zero. Okay. And there is one more point which is also very important, which says that zero acceleration means uniform motion. So whenever we'll have zero acceleration, we'll get a uniform motion. But whenever there is an accelerated motion means a constant accelerated motion. It is not a uniform motion. See, this is a major difference in constant acceleration and zero acceleration. Whenever there will be a zero acceleration, we'll get a uniform motion. But whenever there is a uniform acceleration or a constant acceleration, we'll get a non-uniform motion. So this is very important point which you need to remember whenever you will be dealing with a zero acceleration or a constant acceleration. Okay. So now we'll move on to next point, that is different types of accelerations. So we discussed with the constant acceleration, then uniform acceleration and non-uniform acceleration. So for that, we'll be drawing graphs for the acceleration. If the acceleration is constant, we saw before, the line will be always parallel to the x-axis or the time which will, or the axis which will be showing us the time. Then we will have now a uniformly accelerated motion. When the acceleration is increasing, the acceleration is going on increasing uniformly. When it is increasing uniformly, see, it is written over here that for uniformly accelerated motion, or acceleration time graph will be a straight line. Okay, for uniform acceleration or acceleration time graph will always be a straight line. And for non-uniform motion, non-uniform accelerated motion, will get this type of curve. We'll get a curve. We will get a curve for non-uniformly accelerated motion. Okay. So for velocity time graph for a uniformly accelerated motion. So as the acceleration is going on increasing, the change in velocity will also be very fast. Like कभी गाड़ी चलाए आपने, अगर कभी गाड़ी चलाई होगी, so when we keep giving acceleration, when we constantly keep increasing our acceleration, we see that the change in our velocity is increasing very fast with the time, right? अपनी जो velocity है, अपनी जो speed है, वो constantly बढ़ती ही जाती है, बढ़ती ही जाती है, बढ़ती ही जाती है. And this change in velocity with the increasing time keeps on increasing. So for that purpose, we show a velocity time graph for uniformly accelerated motion will give us a parabola. Okay, what I said, that velocity time graph for uniformly accelerated motion, will give us a parabola. Okay. So now there are some important points which you are supposed to remember. Okay. So the area under the velocity time graph will give us the total displacement at that point of time. The area under velocity time graph. See, if there is some velocity time graph like this, and this is the velocity, this velocity time graph, and this is 1 second of time, 2 second of time, and 3 second of time. And if anyone asks you what will be the displacement when the time is 2 seconds, so we'll come to this 2 second time, and we'll draw this, and we'll calculate this area, whatever will be the area in this portion. So this was our 1 second, 2 second, and 3 second, and we are supposed to calculate the total displacement covered by the body in this time frame of 2 seconds. So we'll calculate this area, and calculating this area will give us the magnitude of the displacement which the object will cover in 2 seconds. Okay, and the same is for the area under acceleration time graph will give us the final velocity, at that point. This is not point of, this should be point of time, at that point of time. Okay, so till this we saw this 1 and 2, we saw about the area, and now from this third point we will be now covering the slope. First of all, what is the slope? See, if you are given, suppose, a curve like this, and if we want to calculate the slope at this point, so what we'll do, we'll draw a tangent at this point, and whatever angle, we'll extend this line over here. We can also extend this. So whatever angle this part will be making over here, whatever angle theta it is making, this theta is called as the slope. Okay, if there is some, say, velocity time graph is given to you, so this is a velocity time graph, and velocity is shown by this curve which I have drawn over here. If this is our curve, and we want to check the slope at this point, so this point A, and if we want to check the slope, so we'll draw a tangent at this point, and whatever angle it will make at on the x-axis, this will be called as the slope. I hope the concept of slope is clear to you. So we'll discuss it for as the application. So the slope for the displacement time graph, slope for the displacement time graph will give us the velocity at that instance of time. Okay, the slope for the distance time graph will give us the velocity at that instance of time, and the slope for the velocity time graph will give us the acceleration at that instance of time. So whenever we'll get a velocity, there will be increase, that is velocity will give us the acceleration, and the displacement will give us the velocity. Now, how to remember this? I have made one shortcut for you, that how you will remember this. So whenever we'll be calculating the area, we are supposed to multiply the units of the x-axis and the y-axis. Multiply the units of the x-axis and y-axis. we saw that whenever we were calculating the area under the velocity time graph, we were calculating the area under the velocity time graph, we got displacement. Displacement is in meters. We got a displacement. So if you multiply the units of velocity and time graph, the unit of velocity is meters per second and the unit for time is second. Is second. And if you multiply this meters per second into second, we see that this second and second will get